So hello guys, welcome to the another video of data structures using Java. In this video we will be starting with the linked list in Java. Linked list is the most important part whenever it comes to the Java, because in languages like C and C++ we have the pointers, and we know that Java doesn't support the pointer. So implementing linked list in Java is a different fun. But in this video we are going to deal with only introductory part. That is, first of all we will check why do we need a linked list, then we will check what is linked list, types of linked list, and what kind of operations we are going to perform on the linked list. So I highly recommend you to stay till the end of this video to get the clear idea on the introductory part of our linked list. Now let's start with our first point, why do we need a linked list. The big question comes in, we have arrays, right? Let's suppose this is an array of size 7. The size of an array is 7 and we have the arrays. Then the question comes, why do we need a linked list? So let's check out why we need a linked list. Now let's suppose we have given an element. Let's suppose I have given you a key called as a 9 and I have asked you to go and insert in this array. Now what you will feel like, okay, I'm going to simply go and insert a 9 at the end of my array. Okay, this is a lot more easier, right? But now what if I tell you I want to insert a key called as a 99, but I want to insert it at index number, let's suppose 2. I want to insert this 99 at this position. How it is possible to insert a 99 at index 2? See, there are two things important that we need to do in order to insert 99 at index number 2. First of all, we need to check if my array contains a space for that 99 or not. We can see that, okay, there is a space available for this 99 to insert. Then the second important thing that we need to do is we need to shift all the elements from index 2 to its right side by one position. So if I move it, how my array will look like? So here it will be 3 and here it will be a 4 and here it will be 9. Now my 3 has shifted to its right side by one position, right? All the elements is shifted to its right side by one position. Now if you see carefully that now there is a space available to insert 99 at index 2. So I will simply go and insert 99 at index 2, right? So see, just to insert an element 99 at a given index, we need to perform three operations. First, check whether my array contains space for it or not. Second, move all the elements from index 2 to its right side by one position. And third, go and insert that element. So we need to perform three operations to insert one element. So this is a lot more costlier, right? Now let's suppose again we have given a one more array, and what I tell you that I want to delete this element too. Okay, what you did is we simply deleted this element. Now array will never contain a space in between, right? We cannot keep one empty space in between. So what we need to do is again we need to shift all the elements to its right side by one position. So here it will be a 4 and here it will be 1 and 8, right? Here it will come 1 and 8. So we have shifted all the elements to its right side by one position. See, again to delete it we need to perform two or more operations. Why we need to perform two or more operations if I only want to delete the element or if I only want to insert the element, right? So these are the disadvantages of using an array. And the last disadvantage is we cannot change the size of an array. Let's suppose the size of array is 5 and I have inserted all the 5 elements in it, and what I tell you that again I want to insert two more elements. Now how we can insert two more elements in this array? Because my array is already filled and there is no any space available to insert these two elements, right? In order to do this, what we need to do is we need to create a new array of bigger size and then copy all the data from my previous array, right? And then insert these two elements. And most important point to note here is that we also need to delete this array, right? Otherwise if you don't delete this array, it will lead to overflow of a memory, because you are creating an extra array every time if the space in my array is filled. So these are the disadvantage of an array. See, just to delete an element, just to insert the element, or if you want to insert more elements than the given size, we need to perform so many operations. And because of this is what we called as a disadvantage of an array, that the insert and delete operations and the given position becomes a lot more costlier, because we need to check whether the space is available for it or not. Then we need to move all the elements to its left side or the right side by one position. And if our size is already fixed, we cannot change the size of an array during the runtime. That is the reason why we need a linked list. So I hope so you understood what are the disadvantages of an array, which will lead us why do we need a linked list. So now let's understand what do you mean by a linked list. So we know that the definition of array is collection of elements. Okay, the linked list also says that it is a collection of elements, but in linked list elements are stored in the form of nodes. and they are stored in a random order. Now the big question comes, what do you mean by node? As of now, don't worry about node, because we are going to see what is node in the next video. Right now, it is a linear data structure, and linearity is maintained by the pointer by storing the address of a next node. Now what does it mean by, see, this is, say, suppose this is one node, this is my second node, this is my third node, and this is my fourth node. And now this node will contain the address of the next node, this node will contain the address of its next node, and this node will contain the address of the next node. And because of this, we call it as a linear data structure. Right now, have you got us why the linked list is called as a linear data structure? Because every single node is storing the address of its next node, and this is what makes us a linked list linear. Now let's suppose I want to store a number 7. I can simply go and put 7. Now see, the element is represented in the form of node. Now as of now, I'm not going to talk about what is the structure of a node, because I want to make a detailed video on it, which will be seen in the next video. But just consider as of now that every element is shown in the form of node. Now let's suppose I want to insert 6, 9, and I have 10. So this is how the elements in linked list are represented and stored. Now there are basically 3 types of linked list, right? That is single linked list, double linked list, and circular linked list. In single linked list, every single node store the address of its next node, right? Store the address of its next node. Now if you see carefully that I'm able to move from this node to the till the last node, but I cannot move from last node to the first node. This is not possible, because this node is not storing the address of its previous node. This is not storing the address of its previous node. Every node is storing the address only of its next node, but not its of previous node. Doubly linked list says that all the nodes store the address of its previous node as well as the next node. See, I'm able to move from this node till this node, and also I'm able to move from last node till the first node, because every node stores the address of its next node and its previous node as well. And circular linked list says that my last node stores the address of the first node, which means I can move in a circular order, right? I can move from circular order. So these are the 3 types of linked lists we are going to see, and also we are going to implement these linked lists. Now while implementing the linked list, what are the operations we are going to perform on it? So basically there are 3 operations we are going to perform on the linked list, that is insert, delete, and traversal. And whenever we talk about the insert, there are 3 different types of insertions we are going to do. That is first insert at start, then end, and at any given position. And we are going to talk about how the performing operations on linked list is lot more easier than performing operations on array, and because of this we need a linked list though we have the array. And then same with delete, we are going to delete the first node, last node, and at the given any random position. And what do you mean by traversal? Traversal is nothing but reaching every single node exact once. Let's suppose this is my linked list. You have to visit every node. This is what we call as a traversal. So these are the 3 different types of operations we are going to perform on the linked list. So I hope so you understood why do we need a linked list, what are the disadvantages of linked list, types of linked list, and the operations we are going to perform on the linked list. Just in case if you are new to our channel, do subscribe the channel for more such informative videos. Till then, see you in the next video of linked list.